Okay, here we go. This one's going to be a little bit of a challenge. Again, you've got to know the nomenclature. Not only do you have to know the nomenclature, you have to write you have to be able to write formulas that goes along with it. And then you have to be able to apply the writing the equation. You have to be able to use solubility rules. And then you can start to think about complete ionic and net ionic equations. Okay, so it gives you the formulas and it tells you what state they're in. So we can start off by writing aqueous calcium nitrate plus aqueous sodium carbonate. Now, you have to understand that it's a double displacement reaction, so the cations are going to switch places. So that means that we're going to be left with sodium and nitrate and calcium and carbonate. Now, you have to be able to apply your solubility rules: sodium nitrate soluble, calcium carbonate insoluble. Once you've done that, now you can balance. And so I need looks like I have two sodiums. I need two of those. It looks like I have two nitrates. So I need two of those. So a stoichiometric coefficient of 2 in front of the sodium nitrate on the product side, that'll get me balanced. Okay, once you've written down the complete molecular equation, you're really kind of done with thinking about the chemistry, because if you know nomenclature, if you know your formulas, if you know how to do reactions, then the rest is just sort of deconstructing the complete molecular equation. The complete ionic equation is the ions as they appear in the solution. So if it's aqueous, we know that ions are floating around in the solution and they're not necessarily bound together with a counter ion, an anion. If it's solid, then they are stuck together in a lattice. And so we write in the complete ionic equation, we write down the ions as they appear. So how do they appear in the solution if they're aqueous? They're isolated. So that means I have a calcium 2 plus by itself and it's aqueous. That means I have two nitrates by themselves and they're aqueous. It means that I have two sodium ions by themselves and they're aqueous. And the last thing on the reactant side is I have a carbonate by itself, aqueous. Now, if you know the formulas for all of these polyatomic ions and the monatomic ions, then you didn't really struggle with this part. But if you don't know those formulas, go back and learn them, because you're going to struggle with this every time. Now, for the product side, the sodium and the nitrate are still aqueous, so I write them down separately, just like I did before. So 2 sodium ions aqueous plus 2 nitrate ions aqueous. Now, here we come to the solid. Remember, the solid is together in a lattice. So the cation and the anions, they're together. So we have to write them that way. And so in other words, if it's a pure solid or a pure liquid or a gas, we just write it down exactly as it appears. So there's your complete ionic equation. Now, how do we get to the net ionic equation? What we're going to do is we're going to cancel out anything that appears on both sides of the reaction. I've got sodium ion and nitrate ion aqueous on both sides, so that's what I'm going to cancel out. What's left is my complete ion, or is my net ionic equation. So I've got calcium 2 plus CO3 2 minus yields calcium carbonate. That's my net ionic equation. So the two aqueous ions come together to form something that's insoluble. That's the net chemistry that happens in the equation from the beginning. Okay, well, what are the spectator ions? Spectator ions are the things that you crossed out. So sodium ion and nitrate ion. Okay, guys, that's it.